So I'm going to open up content drawer and navigate to content, and in here I'm going to create a new pawn blueprint called BP camera. Open this up, and over here in components I'm going to add a new scene. Search for scene, and I'm going to replace the default scene root with our new scene over here. And after that I'm going to search for spring arm, and then I'm going to search for camera. So make sure our camera is under our spring arm over here, right? And while the spring arm is selected, navigate to details, camera. At target arm length, I'm just going to increase the value to something like 600, or maybe you could give it something like 1000. So our camera is a bit more further away. After that, in variables, I'm going to create a new variable called default rotation. Change the variable type to rotator. And after that, from the begin play event node, I'm going to drag out default rotation, and we're going to set the value by getting the spring arm and getting its relative rotation. Right, so connect it like this. After that, I'm going to right click over here and search for the left mouse button keyboard event or the mouse event, and I'm going to create another variable called is mouse button down. So I'm going to set the variable type to boolean, drag it out, and when we press it, is mouse button down is going to be true, and when we release our mouse button, it's going to be false. Drag this down further. After that, from the event tick node, drag this down over here, and after that just recreate the nodes as you see. So before I explain how these nodes work, I want to quickly test whether it all works. So I'm just going to quickly go to our game mode over here. Navigate to class defaults. In the default pawn class, change this to our BP camera over here, right? So compile, and we're going to run our game. Actually, I forgot. We need to reset the position of our player start to be in the middle of our playfield. So I'm going to give a value of 550 in the X and Y axis. We also need to drag this player start up above to around somewhere around 1000, I guess. And then if we were to run our game, we can kind of see our piece moving. So back in our BP camera, in spring arm over here, in the details, we have this option called do collision test. I want you to disable this. So basically this setting enables collision detection for our camera, and obviously for this game we don't really need our camera to detect collision, so just disable that. And then if we were to run our game, you can see our camera is rotating around our playfield, and I guess there are a couple of issues with this. We can't really zoom in or out of our playfield right now. You can see as long as we press the left mouse button, we can actually rotate around our playfield. This allows us to see angles that we previously couldn't see in our 3D Tetris game. And obviously there's a major issue with this, and that issue is the issue I mentioned in the previous video regarding our camera angle changing, making it very disorienting for us to actually move our piece. And the solution for this that I came up with is to basically have a default camera position at all times. So I'll implement it in a minute. But right now I want to implement the zoom in and out feature of our camera. So before I create the zoom function, I want to quickly explain how this group of nodes work over here. So basically, if we press the mouse button, we will set the rotation of our spring arm by adding the current rotation of our spring arm with the current mouse location, specifically in the y-axis, and multiplying that with the orbit sensitivity. So using this variable, we can actually increase the speed at which we get to rotate our camera around the playfield. And these two values that are added together are clamped with this node over here. So we don't want our camera to go too high or too low, and hence we set up this clamp over here. So this whole thing is for the vertical movement of our camera. As I mentioned with this comment, similarly this group of nodes set the horizontal movement of our camera. It works similar to our previous node over here, except we don't need to clamp its value anymore, because there is no issue with rotating our camera around our playfield. And we basically combine all these values together into a single rotation value to be set into our spring arm over here, right? So over here, I'm going to right click and then search for mouse wheel axis. So this node over here, and I'm going to drag the spring arm, search for the set target arm length. After this, I'm just going to quickly recreate the nodes. Just follow along. So we have the code for increasing the zoom of our camera. So compile this, and I'm going to run this. Yeah, our zoom is really slow. So going back over here in our camera, I'm going to set the orbit sensitivity to something like 10. Once again compile and run this game. Yeah, it could be a bit faster, but yeah. Maybe I should create another variable. So zoom sensitivity. Alright, so now it's a lot faster. Our camera is zooming in and out of our playfield, and we are also able to rotate our camera around our playfield. So now we need to implement the logic to get our camera to smoothly rotate back into its default position. So back in our event graph, as usual, I will go ahead and make the nodes first, and you can follow along. Make sure in the R interrupt to node over here, you set the interrupt speed to something like 3, right? And yeah, with that we are done with the code. So compile our game, and we're going to try running this. So I'm going to zoom out a bit, and as soon as I rotate my piece while holding the left mouse button and I let go of my mouse, it smoothly comes back to our default position over here. So once again, rotate it like this, let go of my mouse button, and it comes back like this. And if you want to increase the speed at which it rotates back to the default position, you can give a higher value to the R interrupt speed. So I gave 6 over here. So let's try this out. It's a lot more faster now. So this is the speed you want. You can choose that. So yeah, that's about it for this video. In the next part, I'm going to add the logic needed to detect lines in our playfield and then delete them and move the pieces above to our playfield down to fill in the gaps. So yeah, thanks a lot for watching and see you in the next part. Bye.